Welcome to our tutorial video on understanding oscillatory motion, where we will delve into the analysis of mass spring system. In this video, we will explore the mechanics of vertical spring supporting a hanging block. First, we will calculate the spring constant by examining the equilibrium position when a block of non-mass is attached. In this foundation, we will then investigate the behavior of system when the block is displaced and released, analyzing various aspects of such period, frequency, amplitude, and maximum speed of oscillation. By the end of this tutorial, we will have a comprehensive understanding on how to analyze and interpret the dynamics of mass spring system. Let's start. Let's assume we are given this kind of problems, which says a vertical spring stretch 9 cm when a 1.3 kg block is hung from its end, and we ask to calculate the spring constant, the block. Next thing that happens, then the block is displaced additional of 5 cm downward and release. In part B, we ask to find the period, the frequency, the amplitude, and the maximum speed of the resulting. How can we solve this problem? Alright, let's start with the first one, which says we should calculate the spring constant. Calculating the spring constant, the force exerted by the block hanging from the spring is equal to the force exerted by the spring when straight. So we can use the Hooke's law. Let's see the diagram. Let's say this is the first spring, and we are given its stretches, which is from here to here. It stretches at 9.6 cm. Then later on, the same spring, it was stretched with additional of what? That is from here, additional of what? 5 cm. Remember, this is spring. And we said we're going to calculate it using Hooke's law. Hooke's law is given to be F. Okay, I'm starting with the first one, which is spring constant. Spring constant is denoted with what? Capital letter K. And we're going to be using the word Hooke's law, which is what? F, which is equals to negative Kx. In our data, remember we are given, according to Hooke's law, the F is the force applied by the spring, that is weight of the block. The K is the spring constant. X is the displacement from the equilibrium position. And at this point, this is the equilibrium position. So, and it was displaced to what? 9.6 cm. So, according to our data, we are given X, which is what? 9.6 cm. You need to convert this to meter, which is going to give you 0.096 in meter. What about the M, which is our mass, which is going to be 1.3 kg, and we are given the center of gravity to be constant, which is 9.8 in meter per second. Alright, this is just the data. Let's see how we can solve the problem. We are asked to find what? The first problem asks us to find is the spring constant, which is K. Therefore, K is unknown. We said we are going to use the Hooke's law, which says F is equal to what? Negative Kx. First thing you need to do, you need to know that if we are given F, this is simply going to be mg. And according to the Hooke's law, F is what? Negative Kx. We are going to input the two formulas together. Therefore, F is equal to F, which is the same thing as saying mg is equal to negative Kx. At this point, we can set, okay, K, we are having K here, right? If we move it to the other hand, it's going to be positive since this is negative. So we are going to make K to be the substituted formula. We are going to subtract both sides by what? By X, meaning that X will cancel out, and we are going to be left with we are going to be left with K to be equals to mg divided by X. So our spring constant K is equals to M. Our M is what? our m is 1.3 in kilogram, multiplied by what? 9.8 in what? Meter per second square, which is gravity, divided by x, which is the what? Displacement. That is from the equilibrium position. What is the displacement from the equilibrium position? It's given in meter per seconds, right? No, it's given in centimeter, and we have converted to meter, which is what? 0.096 in what? Meter. At this point, we can cancel out meter per seconds, and the unit of spring constant is what? Newton. If you compute everything and divide by 0.096, this is simply going to be 133.54 in what? Newton per meter. So this is our spring constant. Find a good space and write it down, because we are going to keep on using that continuously. Okay, next thing we need to find is what? Is the period. What is the formula for finding period? Formula for finding period is what? T, which is what? 2 pi omega. And not that omega is the same thing as writing square root of what? M divided by K. And remember, our K is given to be 133.54 in what? Newton per meter. Therefore, our time period is simply going to be 2 pi multiplied by the square root of what? M divided by K. Therefore, time period is what? 2 pi the square root. What is our mass? Our mass is 1.3 kilogram divided by 133.54 in what? Newton per meter. Therefore, our time period, the unit for time is what? Second, which is what? 2.06 in second. That is if you divide and multiply everything by 2 pi. The next thing, that is the part C, we're asked to find is the frequency. We said time is equal to 2 pi omega. Our frequency is what? 1 divided by period. Therefore, frequency is simply going to be, our frequency is simply going to be 1 divided by time, which is the same thing as same frequency is simply going to be 1 divided by 2 pi to the square root of what? M divided by K. We're not going to complicate things. Let's just stop here and say frequency is what? 1 divided by time. Frequency is what? 1 divided by 2.06 in second. If you punch this on your calculator, this is simply going to be our frequency. Remember, the unit is in hertz. This is going to be 0.485 in what? Hertz. So next thing we need to find is the amplitude. Let's erase everything here. How can we find the amplitude? The amplitude is the maximum displacement from the equilibrium position. That is, given block was initially displaced, we have the additional of what? 5 centimeter. We need to divide that, or we need to convert centimeter into meter. Centimeter into what? Meter. We have 5 centimeter, and we need to convert that into meter. This is the same thing as saying 0.05 meter. In this case, our amplitude, the initial is what? Is 9.6 centimeter, which is equivalent to 0.096 in meter. Our amplitude is simply going to be the 0.05 in meter. We are going to plus it with what? Point, which is displacement of A and B. We are going to plus it with 0.096 in meter. Our amplitude, if you plus everything here, is simply going to be 0.146 in meter, and this is it for the amplitude. The last thing we are asked to calculate the maximum speed. in this problem. Alright, next thing we need to find is to calculate the maximum speed. In this case, maximum speed is denoted by Vmax. Vmax, this is what we asked to find. The maximum speed occurs at the equilibrium position. At this point, all potential energy is conserved into kinetic energy. I'm sure you are already familiar with kinetic and potential energy. So, but in simple harmonic motion, remember potential energy relies on the amplitude. In this case, we can say P, let's say PE, that is the potential energy, in max is equals to KE max, which is the same thing as saying potential energy is equals to the kinetic energy. Alright, since potential energy relies on amplitude, this is simply going to be a half Ka square. For the kinetic energy is what a half relies on velocity mv square. Next thing we need to do is to multiply both sides by 2. This is going to be a half Ka square divided by, equals to a half mv square. 2 multiplied by 1 is 2. 2 divided by 2 is 1. 2 will cancel 2. We're going to be left with nothing there. In this case, 2 will cancel out. We're going to be left with Ka square to be equals to mv square. Since we need to find the maximum velocity, at this point what we need to do is to solve for the maximum velocity, making v to be the subject of the formula. In this case, this is going to be v max is going to be let's just divide, let's make it easier by dividing both sides. By dividing both sides by the maximum velocity, we can say let's divide everything by v, or let's just say v square. This will cancel out. Or we're trying to find that out, v, that is the maximum velocity. Let's just make it to be the set of the formula, which is going to be v max. At this point, if it cancels out, we are going to be left with m. And here, we are going to be left with what? Ka square, square root of k square divided by m. Let me take a quick revision here. At this point, after multiplying everything by 2, the 2 will cancel out the, a half from the amplitude, from the potential energy and the kinetic energy. We are going to be left with Ka square, which is equals to mv square, making v to be the subject of the formula, since that is what we need to find. Okay, let's try to divide everything. No, making v to be the subject of the formula, we're going to divide everything by m. This is simply going to be m, it's going to be m. M will cancel out. V square is the same thing as what? Ka square divided by m. Remember, this is in square root. For us to get rid out of it, we are going to say V max, which is maximum velocity, is going to be what? The square root of Ka square divided by m. So our V max, which is the maximum velocity, is going to be the square root of k. What is k? Which is the spring constant. This is simply going to be 133.54 in Newton. Let's write it here. V max is going to be the square root of k, which is what? 133.54. We're going to multiply that by amplitude. Our amplitude is what? 0.146 in meter, also in square, divided by m, which is what? Our mass, and at this point our mass is what? Is 1.3 kilogram. If you punch everything in your calculator, our maximum velocity is simply going to be 1.69 in meter per second. So we can finally conclude and say our spring constant, which is k, is given to be 133.54 in Newton per meter. Our time period is given to be 2.06 in second, and we're given the frequency, which is what 0.485 in hertz, and the last one, which is amplitude, A, is given to be 0.146 in watt meter. Then the maximum velocity is going to be 1.69 in meter per second. So this is it for this problem. Thank you for watching. See you next time. Don't forget to subscribe to my YouTube channel for more videos like this. Goodbye.